In this presentation, we're going to talk about mesh networking within Ruckus One. Typically, the APs that you'll have in your environment are going to be connected directly to a switch with an Ethernet cable, and that's the best option for the performance that the AP needs to provide to the wireless clients that it's servicing. However, in some cases, that's not always an option, and that's why we want to talk about mesh networking. So if you have, let's say, a historical building that you're not able to modify the environment of, maybe you're not able to run a cable through a particular area or through a wall or through a ceiling or floor, you might instead need to use mesh to build a wireless link to a device that is hardwired. You also might not be able to run a cable if it's just not cost effective to do so. So it doesn't necessarily have to be that it's, the building's unable to be modified or something like that. It could be that it's just not cost effective to run that Ethernet cable. In those cases, using mesh might be the best option to extend the Wi-Fi coverage to the areas that you need to reach. We're going to first talk about some topologies that you can use within a mesh environment, and then we're going to move on to some considerations that you should think about before actually deploying mesh. In a standard mesh, we've got the idea of root APs and mesh member APs. So root APs are the APs that are hardwired into your switching infrastructure, and then our mesh members are wirelessly connecting over to those root APs. So we may use 2.4 gigahertz radios or a combination of 5 gigahertz and 6 gigahertz radios on the mesh to make that link over to the root AP. And then again, these member APs can serve clients. So that's the whole idea of putting a mesh out there. You want to extend your Wi-Fi coverage for clients, and you can do that over the same radios that you're using to create that wireless link over to your root AP. So we'll talk a little bit more about that. When we're looking at the UI within Ruckus One, you're going to see root APs designated as RAP and mesh member APs is MAP. We've also got the idea of a eMesh topology. So this is where you have root APs and you have mesh APs, but on some mesh APs, a lot of our Ruckus APs have multiple Ethernet ports. So if you have a mesh AP, but then you plug in another AP into the Ethernet port of that mesh member, that then becomes a eMesh AP. So we'll talk about, some considerations for that and how that kind of topology works in terms of hop count and bandwidth availability. Before enabling mesh in the environment, there's some considerations that we need to make, primarily around, the RF limitations within the physical space, the actual AP placement of any mesh members. We have to make sure that we understand what the mesh tree looks like and how many hops that we anticipate for our mesh network. If you are not in the US, there are some considerations if you are trying to mesh indoor and outdoor APs. And then, before we actually mesh anything, we need to make sure we pre-stage these APs with a cable connection so that they can actually get their configuration for the Ruckus One firmware before we then move them to their final location. So let's dig into a little bit of detail on each of those points. With regard to the RF limitations, when using 2.4 gigahertz for your mesh, you're going to have lower overall bandwidth available, less free channels within your environment, but 2.4 gigahertz will operate at a longer distance. So you might be able to mesh better to a node that is further away. Whereas with 5 and 6 gigahertz, you're going to have more bandwidth, more channel availability, but you won't be able to cover as far of a distance with that mesh link. Mesh member placement is oftentimes dictated by where there is available power for those APs. Again, these mesh members do need AC power, so a lot of times we see that they are placed next to a power source. So you need to consider that when you're thinking about where to place these members. And then once you've determined where they're going to go, a lot of times that kind of also dictates which radio band you're going to use for your environment. So now you have the physical layout for where this mesh member link is going to live, and you can see what the RF in that area kind of looks like and determine whether or not you're going to use the 2.4 or the 5 and 6 gigahertz radios. When you're designing your mesh tree, you want to typically keep it around 1 or 2 nodes deep. You typically don't want to extend it beyond that because every time you add a mesh link into the tree, you're cutting your available bandwidth for those clients in half. If we look at an example here, we do have a mesh with 3 nodes in it. So we do have a 3-node tree, and we can see how the bandwidth is actually impacted as we move down the tree. So for the first hop, we have the full amount of bandwidth, 300 megabits. Once we get to the second hop, it's reduced by half. So now we only have 150 megabits. If we look at the third hop, again, we reduce by half, and now we're 75 megabits. So the users that are connecting down at that third level have substantially less to work with than the users connected at the first hop. So really, when you're talking about how you want to design your mesh, you need to consider what applications are going to be used within where you're extending that Wi-Fi. And if you're talking about voice and video applications, you want to make sure you're not in a scenario where they don't have enough bandwidth to be able to support the application. For our non-US friends that have region-specific indoor and outdoor channels, if you were trying to mesh an indoor AP with an outdoor AP, you're going to first need to make sure you use non-indoor channels to at least establish that initial connectivity. We do want you to check the latest Ruckus 1 release notes to make sure that that is still the case, but be prepared to do that if you are trying to mesh indoor and outdoor where you have those differences in channels. Before trying to set up mesh member APs, you need to have them staged. So you will need to connect them into a Ethernet connection, get them loaded into Ruckus 1, get the Ruckus 1 firmware downloaded, as well as the venue configuration downloaded onto them. So at that point, you should have already enabled mesh on the venue so that the venue configuration for mesh is already pushed down to them. Once those APs have been onboarded successfully, you can then disconnect them from the Ethernet connection and move them to their final location, and you will be able to successfully establish a mesh. At this point, we're ready to enable mesh, and we do this from a venue level. I'm going to enable it on the home network here, so I'm going to select home network. I'm going to go up to configure, Wi-Fi configuration, networking, and we can see we have mesh listed here. So by default, it is disabled, and we can choose the radio slider to on. We have a few different options when we do that. We have the ability to reconfigure the mesh network name as well as the mesh PSK. These are able to be changed, but we do not recommend doing that unless you have a specific need to do so. We then are able to select which mesh radio we want to use to establish our mesh connection, and you can see by default it is using 5 and 6 gigahertz. I will say that to change this later, you have to disable mesh and then re-enable it and reselect the 2.4 gigahertz radio. So you should determine what you need based on your RF environment before doing this, just to have the least impact. I'm going to leave the defaults here for everything and choose save. I will say that enabling mesh on the venue is impactful to the APs within it. So you should be doing this on a brand new venue, or you should be doing this when there is least impact to clients that use the WLANs in that venue. With mesh enabled for the venue, we're now ready to add some additional APs. You can see that the APs that we already had in the home network venue have been designated with the mesh role of root AP. So both of these guys are cabled in to a switch and can serve as a root. The first thing that we need to do, however, is add another AP. So we're just going to quickly do that by clicking Add AP. We're going to put it in that network, in the home network venue where we have mesh enabled. We're going to call this test mesh and give it its serial number. Now remember when we talked about staging the APs, we need to make sure any mesh member that we have is staged with a cable first so that it can get the initial configuration. So I've already done that. I'm going to go ahead and add the AP here into the home network, and we'll come right back as soon as this guy is operational. If you have the AP LEDs enabled in your environment, you are able to use those to help you determine what the current status of mesh is on devices. On the left-hand side here, we're seeing our traditional 5 LED layout, and we're particularly concerned with the air LED in terms of determining the mesh operation. On the right-hand side, we're displaying our new APs that have a single LED to help you determine what that status is. And we have called out here that if you are showing a slow flash green, which is one flash every 500 milliseconds, that means that we not only have one client connected, but we are also established on a mesh link. I would direct you to product guides for additional information and details regarding LED operation. Now we can see that our test mesh AP is operational and it has a mesh role status of MAP or mesh AP. Let's take a look at the mesh venue settings for the home network. We're going over to the home network and we're choosing devices. And then under the Wi-Fi tab, we have a mesh list button that we can click. So if we click on mesh list, we are given a breakdown of the mesh APs within our environment. And you can see that there is a plus mark next to our R760_35 AP. And if we select that, we can actually see that the 760 is our root AP and our test mesh device is actually linked to that particular AP. And we are also given signal strength here. So this signal to noise ratio is how well each radio is hearing the other radio over the noise floor. So the first number of 26 here is how well the mesh AP is hearing the root AP, and the second number of 23 is how well the root AP is hearing that mesh member. Now, the numbers that we're seeing here fall within the very good to low signal range, so 3 to 4 bars to 2 bars. Typically, you wouldn't want to see anything less than what we're currently showing. And I'm going to bring up a little graphic that outlines the SNR and the description for the SNR. Typically, if you're seeing something that is 1 bar within the 10 to 15 dB range, you're going to have issues even staying associated with that mesh length. So you're going to want to probably try to reposition the devices if you can to try to get that signal a little bit higher, or use a different radio band. Again, we're using 5 and 6 gigahertz radios here to establish this connection. So this is a way that you can kind of measure the quality of the signal for this mesh link. Also notice that we have a hop count column for this mesh list. So we can see that our test mesh is 1 hop away from the root. So again, when we're trying to calculate the tree and figure out what kind of bandwidth we have, we can utilize that hop count, and we know that we need to decrement by 50% anytime we are more than 1 hop away. I do want to point out that eMesh members will not show up in the mesh list. They will show up in the regular AP list, and they will also have the ability to be root APs themselves, but they do not show any special mesh role designation. When we're talking about hop count, eMesh members do not increase the hop count. So if we bring that image back up, we can see that we do have a eMesh node connected at this second hop level, but we're not actually increasing the hop count. So just as that second hop has 150 meg available bandwidth, so do the clients that are connected through the eMesh AP. From the perspective of an individual AP, we do have the ability to modify how it participates in the mesh. If we go under the networking tab and then scroll to the mesh section, you can see here that we're able to adjust the role for this particular AP's involvement in the mesh. By default, it is set to auto, which means it's going to go ahead and pick the role assignment automatically. Typically, if you've got an Ethernet connection that is working for this AP, it's going to go ahead and want to favor being a root AP. However, we could also force it to be a root only or a mesh only, or we could disable mesh for this particular AP entirely. So in the example of an eMesh AP, you might want to go ahead and disable that particular node from being a mesh itself, because by default, it would be a root AP, but you could go ahead and disable it there. We then have the ability to change or modify our uplink. By default, it's going to be able to automatically select the best uplink, and this is the recommended setting. So if you've got an environment with multiple mesh devices, it's going to look to see which one has the best signal to noise ratio, and if one starts to fall out of favor and another one has a better connection, it's going to switch over to that. However, if you do select the uplink AP manually, you are given the list of the APs that you could potentially mesh to, as well as their current signal at the time. I will warn you though, so if you select an uplink manually, it's only going to use that AP as the mesh uplink. If for some reason that AP goes down, you're not going to be able to have a mesh on that connection. It's just going to go down. It's not going to try to search for any other mesh members to link to. It's just going to be down until that particular AP comes back online. So I would recommend using this very sparingly and let it try to automatically select that best uplink. The final thing we're going to talk about is the venue floor plan. So if you've got a floor plan that is loaded into your venue, you can come over to it and make sure that you've selected Show Mesh Topology, and then we're given some icons for the placement of those mesh members. Now, we did have to place the mesh members. They're not automatically triangulating the location, so I have placed the devices, but we can see the status of all of the devices here. So we can see my root AP, one of my root APs, but you can see when we hover it is not linked to any mesh AP. And then we do have our mesh over here, and we are identifying that it is linked to root AP 77036, which is actually on my second floor. So if I switch over to my second floor view, we can see that 77036, and we are linked directly to one mesh AP. So this is another way that you can quickly determine kind of what the connections are for the mesh members within your environment.